So hello everyone, I'm Vitor Louzada. I work at Bank Itaú. I'll be talking today about how we use machine learning models to predict the physical money demand that we have at our branches. Just a quick introduction, Itaú is the largest bank in Latin America in terms of assets. We operate in more than 15 countries with dozens of millions of clients and thousands of transactions per second. And from a data science perspective, it's just an amusement park. Terabytes of data generated every day, and we can do a lot of stuff with all of this. For the particular problem we are talking today, so money allocation, it's a huge challenge. As you know, Brazil is a continental country, and we have branches in almost every town, so it's more or less 4,000 of them, with billions of physical cash in circulation. And just to give a perspective, at the time of this recording, the real is more or less 7 to 1 to the euro, so it's serious money that we have trapped in physical form at the branches, with millions of costs per month for this particular optimization challenge. The Brazilian cash ecosystem is also a complex network of players. On the supply side, we have the Banco do Brasil, which is a government-run bank that acts as a lender of last resort, but then you need to pay some fee to withdraw money, to get money from there. But we can also share and exchange money for like electronic money for physical money with other banks. And after that, you have thousands of small units like small treasuries, small transportation, and the branches themselves have some safes there, the ATMs. Also, big retail consumes a lot of physical cash, people and companies as well. So every arrow you see here represents a multitude of models that we have to build, and of course, everything has to run in harmony in order the system to work. So from a business perspective, the challenge we have here is how to make sure our clients get the money they need when they need. Nobody likes to go to a bank and then there is no money there to withdraw. And also we cannot overstock, otherwise you have some nice security issues here. So going a bit into detail, technically we model this as two different challenges. One is a demand prediction challenge and the other is the optimization part. The optimization problem is just a balance between costs and risks, which is like transportation cost or opportunity costs, because all this money trapped in physical, as a physical thing, it cannot be invested in some financial instrument. And from the risk perspective, you cannot risk getting your client down, so they have no money there, and then it goes and there is a stock out, and also security. The branches can actually be robbed. It's still a huge problem of violence in Brazil, so you always need to consider that for each one of them. Because we had to do this allocation in some days in advance, for some part of the problem is a few days, others is like 15 days, you need to give the orders for the transportation guys to move money around. We noticed that demand prediction bit with machine learning would be a lot of help, and I'll be focused on this part for the rest of this talk. So we model each branch as a time series of net deposits. So this is like deposits minus withdrawals. And we want to predict it in the next 15 days. And how we did that was basically to treat it as a time series problem, but with a machine learning approach. So we built hundreds of features for each branch with stuff like the mean value of net deposits in the last 3 days, 10 days, 30 days, year, etc. Or median value, or max value, minimum value, so on and so forth. So you got hundreds of features with a certain target, which is what will happen in the next day. And with this formulation, we managed to build one machine learning problem for each branch, because each branch has its own history, basically, so it had a lot of data for each one of them. So it became a different sort of big data approach. You don't have a huge data set. You have several thousands of small data sets that you have to make an accurate prediction. And of course, you can treat it as a machine learning because you need to use stuff like this temporal cross-validation strategy, where you consider that you're always adding new data at the end to make a 15-day prediction. We got some nice results. At the beginning, we prototyped it in R and Python and linear thing. You have like 15 hours of execution just to predict something for each one of the branches for the next 15 days. So after a while, we had to step up and go to Spark, so this in a distributed fashion. And then we got down to 1 hour, which was much better. And this was really much better than the traditional approach, which was a more econometrics strategy for time series, and also considered one time series for the whole bunch of branches. So it wasn't very precise. And with machine learning, opposed to regular time series things, you are more concerned about error, not about the explanation of what was happening. So just using this was a quick win. We had some problems with demand peaks, which is the nature of cash demand. So people usually get paid in a single day, and then they go there, withdraw everything. And when there is deposits, there are more scattered along the month. So because of these peaks, usually we were making a lot of underestimations, which is not good. So just by changing the error function, we got some interesting results by doing more penalty to underestimation. The errors got slightly better, and peaks were also a bit better, but not so much. Up to this point, you see I'm talking about 2 versions here, so this is more or less 6 months work in a small squad with 2 data scientists, some engineers, some business guys from the cash distribution part. Just a regular data science thing. But we noticed that we were not getting new results, or it would be much harder to get a V2 that would, out of this the regular, usual strategy to actually solve our demand peak problem. So what we did was a small hackathon at Itaú. So we gathered more or less 100 data scientists, put them in a single day to think about this problem, and they came up with very interesting information, looking at the data and trying to do a better model, a better predictive model. Like holidays need to be added explicitly, so this is one particular drive of demand peaks. You can consider the commercial strategy of each branch. So each branch, for instance, a branch in a small town can get a new payroll contract from a large company, and suddenly you have hundreds of people going to this branch to withdraw money the same day. So if you get this information in advance and then you add it and you consider it on what you learned from other branches, then you can be more prepared to this sort of stuff. And of course, the data science part with new features and new models you can get, people get very creative at this point. One particular problem we identified at this moment was the resonance of demand peaks. So stuff like there is a payday on a Monday before a holiday. So each of these things would increase the demand peak a bit when they happen. So paydays, Mondays, and holidays, or day before a holiday. But when they happen together at the same time, then you have an explosion. So you have like overflow of people going there, so trying to withdraw money. And of course, because of, let's say, quite traumatic history, you don't want to have a bank that runs out of money. So our NPS scores were really bad at this moment, so we need to take care of with very care and to increase the customer satisfaction at these occasions. So when we spoke with the business guys that were managing the cash distribution, then they explained to us that they already had some strategy in place. So when there is something like this that will happen, they look at the past and see a similar month that something like this happened. So then they just repeat what happened in the past. So it's a very specialist approach to learning. So it was a very specialized person that was doing this, and but it was more like a comparison. So it was done every month more or less to correct for this demand peak. So what we did was just to automatize this, make it more algorithmically. So we model each month as a vector feature, a vector of features, where you consider stuff like number of weekdays of the month, number of holidays, if the day of the week of the fifth day, which is like the cultural, the traditional payday in Brazil, and once you have for each branch, each month of their history, in for comparison, you can find the most similar one using cosine distance. Then you can get something very interesting, like the plot here at your right, where you can find a very similar month, and then we use this after the machine learning bit that was explained, just to correct this small demand peaks when they happen. So it got very nice results. So everything was working perfectly until the coronavirus hit. So you can imagine that almost all branches were closed at different rhythms, and everything was very confusing to use machine learning at this moment. So what we actually managed to do was to contribute to this project there, where Itaú made some donations of money and technology to hospitals to help fight the COVID-19 crisis. So we built for them a system to predict new COVID-19 cases for each town in Brazil, where you just see for the next 15 days, which city is getting worse, so that you could manage your focus for donations or help to those particular places. So you see, it's not really, it's a bit different from maybe what you saw on LinkedIn during the crisis, that everybody was doing a coronavirus curve to predict what will happen. So it wasn't a very epidemiologic approach. It was a large scale prediction. So we had to have one curve for each town, and with not a very precise thing, but a more, in general, we should be able to drive the direction of the crisis. More or less, each state in Brazil had its own curve of infection and decrease, and now second wave. So this was very useful for the decision makers at the large project. We came up with, in the end, a dashboard that was just ranking which cities would be best or worst in the next 2 weeks, so they could drive the effort there. So basically, that's it. I'm glad to discuss any other details that I couldn't talk in this presentation. You can find me on LinkedIn, or you can just write to me and we just catch up after this. Thanks a lot.